This video is on simple ionic bonding. The first thing I'm going to talk about are valence electrons. Valence electrons, spelled V-A-L-A-N-C-E, and I use this symbol E-1 for electrons, are the outermost electrons. The outermost electrons on any individual atom. Okay, so these columns I've numbered on a table over here are 1 through 8, and they count the number of valence electrons on the atoms in that column. So column 1 over here has 1 valence electron, column 2 has 2, 3 valence electrons, column 5 has 5, etc. up through column 8, which has 8 valence electrons. Let me erase. Now, what we want to deal with is every compound, simple ones, that forms wants to have 8 valence electrons. That's what's called the noble gas configuration, because these are the noble gases and they're the most stable electron configuration, which would be 8 electrons in its outer shell. So now I'll talk about how the electrons go into the shells. In the first column, it's easy. So if I take hydrogen, I just put 1 electron, and the dot's what I use for an electron. For the second column, for example, magnesium has 2 electrons. I can represent them like this, or as a dashed line. Boron, or the third column, aluminum, boron, we have 1, 2, then 1. Now's where it gets a little bit tricky. Okay, when we go to the fourth column, carbon, we put them in like this, separate, 1, 2, 3, 4, as far apart as possible. Then nitrogen, and they go in 1, 2, 3, 4, 5. You can see what's going to happen here. The oxygen column, 1, 2, 3, 4, 5, 6. Fluorine, 1, 2, 3, 4, 5, 6, 7. And neon has 1, 2, 3, 4, 5, 6, 7, 8. Notice I've done this 2 different ways. Here I show an electron pair. Here I show the 2 individual electrons in pairing. So you got to know this first. Let me erase. So for something like sodium chloride, we know the formula from outcome 2, NaCl. What happens is everything wants to get to this column over here, the noble gas configuration. So the easiest way for sodium to get a valence electron configuration, their outer electrons, over to this column, is for it to lose 1 electron. When it loses 1 electron, right here, it goes from 11 electrons to 10 electrons. We shouldn't have drawn on top of that because you can't see it. There it is, 10 electrons. Sodium wants to lose 1 electron, so it goes from this to this with 8 electrons around it, and it is now positive. Another way of writing it is this way, and you'll see it 2 ways, and we'll accept both. Sodium plus, like this, with no electrons representing it's lost all its valence, or sodium plus like this, representing the 8 valence electrons from that column. So let's look at chloride, or chlorine, sodium chloride. So chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons like that. It wants to gain 1. Okay, so if it gains another electron like that, it becomes negative. So the chloride ion looks like that, and it's -1. We can also draw a dash in here, so I could have drawn it like this. Wow, I'm running out of room. 2, 3, 4, -1. Okay, so let me erase with that in mind. The Lewis dot structure for sodium chloride becomes either this, and it's positive, so all ions get a bracket around them, and chloride, the sodium, and the chloride. Now we have to show the electrons here. There's my electrons on chloride. Notice that L here looks like the L out here. Be careful with that. And this is -1. So I have a charge up here on the sodium and a charge on the chloride, indicating an ionic compound. The other way to represent it is sodium with 8 valence electrons around it, plus 1, and the chloride with 8 valence electrons around it, minus 1. Either way is acceptable. Let's do another example. How about magnesium bromide? Now we know the formula for magnesium bromide is MgBr2. So magnesium is right here. We know it's a plus 2. It has 2 valence electrons. It loses 2 to get to this column. So magnesium is going to be plus 2. So we write the Lewis dot structure for magnesium with a bracket around it. I'm going to put my valence electrons around it and a plus 2 out here. And now we have 2 bromides in here. Let me erase this a little bit. So I have to draw the Lewis dot structure for both bromides. So here's one bromide, and it's minus 1, and here's the other bromide, and it's minus 1. The bromide has gained one of the magnesium electrons, so the magnesium has transferred 2 electrons, 1 to each bromide. One of them went here, and one of them went over here to this bromide. Now, of course, you don't have all those arrows drawn in here when you draw it. You got a lot of other work in here. I can erase easily, but you should probably circle your answer when you're done if you have a mess. So that's ionic bonding in a nutshell. Practice the problems. Practice the self-test.